Good afternoon, folks. Chief Meteorologist Nick Lilia here in the Severe Weather Forecast Center. Back in behind the studio, you can see back in. You'd think after doing this for quite some time that I'd be decent at looking forward and looking at things behind me. But anyway, we're back in behind the set. You can see it back there. Looking at the severe weather threat as we head through the next couple of days. Really, this is for late Friday and into Saturday morning, unfortunately. So if you have any Friday night plans and they do involve being out late, maybe you have some kids that want to go out and hang out with their friends late Friday night, and maybe just kind of keep this in the back of your mind. This is one thing that we are looking at and keeping a close eye on. I think Friday, for the most part, is going to be relatively dry. A couple of hit and miss showers, but as we kind of get closer, we, like I always say, we get kind of a better idea. The window gets smaller and smaller the closer we get. And as it looks right now, most of the day Friday, probably looking okay. If you need to mow the lawn, wash the car, though I wouldn't recommend it given how much rain we might be looking at over the weekend and into next week. But if you want to get it done, Friday's the day to do it, because as we head through the evening and into the overnight hours, perhaps even into Saturday, we're looking at a chance for some more severe weather. So what we do here, this isn't necessarily a forecast for you. I know I post these things up all the time, but just in case this is your first go-around with these, this is basically a breakdown of why we're looking at the opportunity for severe weather. I like to do this a lot of times for the folks that are just kind of interested in weather, want to know more about it, or if you've ever watched the weather at night and you're going, well, how the heck did they even come up with that? This is how. And it also goes to show that despite all the cool stuff that we can look at, there is a margin for error here as well. So anyway, we'll get right into it, and this one is actually going to be relatively long, so buckle up, I guess, so to speak, because we're going to dive right in. So we're going to start, like I always like to do, up here. Here we go. Hold on. Aha! Up here at 300 millibars or so. And again, this is way up in the atmosphere. And I like to do this because you can get kind of an idea of where the air is coming from. And we're doing one of those guys. So there's your jet. You got a big area up here. And then we've got a little guy back here. Cold front, warm front. You guys get kind of the idea. And I know it's kind of tough to see on here, we in Mississippi are right here, and the Pine Belt is bullseye right about there or so. The reason that I like doing this is I can switch back and forth between all of these, and as you can see, I'm going to leave the red lines up there so you know exactly where you're supposed to be looking here. Okay, so 300 millibars, we got winds coming back out of the south and west. I always say that we're looking for these isobars to kind of spread out. Looks like we've got some a shortwave ridging, so to speak, out ahead of this. So the window for severe weather is going to be pretty slim as we head into Friday night and Saturday morning. This is a look at the 500 millibar relative vorticity. Notice that we've got a lot happening to our northwest, a little bit back off barely to our north and west. And again, we're still bullseyed up here, Mississippi and the Pine Belt. And then as we head down a little bit farther, and then again as the numbers go up, we're actually getting lower, closer to the surface. Now we're at 700 millibars or so, 6,000 meters up, about 18,000 feet. And again, we're looking at vertical velocity here. So this is how much a little parcel of air, as we like to call it, or you can think of it as a little pocket of air, how much it wants to move up, or how much it's being forced up. Does it have any vertical motion to it? And notice around here, not necessarily high, because there's your zero marker is everywhere. I want to clear that out. Everywhere that you see nothing, out here, back in here, out over here. We've got a little bit just off to the northeast in some of our northeastern counties, but generally speaking here, we're looking at anywhere between 0 and -3. Not necessarily high, kind of low. Notice where we've got a whole heck of a lot, parts of Kentucky, and then back off to our west as well. Circle us back up again. And then as we go down a little farther, again, numbers go up, we go down. There's our dew point at 850 millibars. I like to look at this because this is about 1,500 meters off the ground, about 4,000 feet or so. And it's a good indicator of how much moisture you have available in kind of the lower levels of the atmosphere for these showers and thunderstorms to work with. Yeah, we love having that moisture at the surface, but do you have any that's a little bit above the surface for these convective cells to kind of work with? And As always, it is the Mississippi Gulf Coast, so we've got plenty of that. It's not like parts of Texas and Oklahoma where they're just bone dry back and behind the cold front. We've got plenty of it, dew points running up and around 10 to 13 degrees Celsius or so. So we've got plenty of moisture to work with down here. And we'll take it into the winds at 850 millibars. I like to look at this, especially given what we're looking at for tornadic development and for getting those rotating updrafts. You know, if you've got all the winds going the same direction, it's really hard to get any rotation in there, obviously, because everything's going the same direction. That's through the column of air as you move up. We oftentimes talk about shear. You want winds at the surface to come out of the south, or maybe, I'll do this for you guys, out of the south, or maybe out of the south and east. You don't really want it to come out of the south and west. And as you move up, you want it to shift from south or southeast back around to the west. So you're getting that turning with height. So if I'm a little parcel of air, and here I'll draw it on the screen here. If I'm a little parcel of air, we're going to draw some land. Here's your wonderful house. It's a great house, 3-bed, 2-bath, brick home with a basement and a storm shelter. Thank goodness. But if you're sitting here, you're at the surface. You want winds, maybe we'll call this out of the south and east. But then as you move up in the atmosphere, because you got clouds up here, and then you got rain coming out of them. But as you move up even higher, and as these clouds get bigger and bigger, you want that to shift back around to the west, so that parcel of air has a tendency to curl and spin around as it moves up. And that's how you get those rotating updrafts. So anyway, and again, a beautiful home that you guys have. I really like the granite countertops. We'll go ahead and shift over to the precipitable water. And again, this is, another measure of how much moisture we'll have. I like to look at this. Are we looking at proficient rainmakers? Gulf Coast, so yeah. Actually, we're looking pretty decent. I call them PWatts for short. A lot of people do. Up around 1.5 inches or so. So we've got plenty of water to work with. That'll be sucked up into these clouds. Now, let's talk about instability. CAPE is a measure of instability. It's how much energy you've got out there as you're lifting these parcels of air up. How fast do they want to go? How much oomph do you have, so to speak? Not a whole lot, though we'll find out here in a couple of seconds. That's not necessarily a terrible thing or a good thing, depending on how you're looking at it. But according to the NAM here, and again, that's what we're looking at, 12C NAM. I probably should have mentioned that off the top. We've got anywhere between 400 and 1,000 joules per kilogram, and where you see the colors change here, especially back off to the western parts of Texas, and that's where the numbers get a little bit higher. Around here, southern Mississippi, you like to get showers and thunderstorms off the ground above 500. You'd like anywhere between 500 and 1,000 for some good severe thunderstorms and a tornado. Anywhere above that, you can still get them, but you're getting out of that perfect window. And again, we'll talk more about that in a second. Coming up on Sunday, late Saturday and into Sunday, perhaps even into Monday, we'll be talking about CAPE values actually a little bit closer to this 2,000 and 3,000 range, but that's for another conversation. Lifted indices. Again, lifted index. We're lifting things. We're lifting that parcel of air. The cool thing about lifted index, and notice all the numbers over here go into the negative, and we've got a whole bunch of negatives over here. And I know you're probably going, okay, negative numbers, that's got to be a good thing, right? That's the air sinking because it's going in a negative direction. It's not a positive thing. Unfortunately, because we use pressure to figure this out, negative is actually going up rather than down. I know it's a little counterintuitive. But if you're looking for high lifted indices, you're actually looking for very negative lifted indices. We're going to have that anywhere between a -5 and a -8. And again, this is late Friday and into Saturday morning. We're not talking about Friday afternoon. LCLs, this is the cloud base. You want those nice and low. We're going to have that. It's not like out in the plains where they've got LCLs up around 2,000 meters. Now we're talking about helicity. This is that spin in the atmosphere that I was talking about, and we are anywhere between about 150 and 250 meters per second. You get up around 300 as you head north of I-20, and I think it's probably going to stay that way. And helicity, the 0 to 3K helicity, again, that's in that same ballpark. Let's see if I can't find it. There's your PWatts. surface cape. Okay, so that's in the same ballpark as, I'm trying to find you guys some shear here, is the shear from 0 to 700 millibars or so, or 850 millibars or so. So anyway, we'll go back to Helicity. Now we're looking at bulk shear through 500 millibars. Again, we're mighty good, up over 60 knots. That's plenty for us, even perhaps approaching a little too much. Up above 40, down at surface to 700 millibars or surface to 3K. And now we're looking at the crossover winds, and I'm going to clear this out. You remember how I was just mentioning I made our little house and it had nice granite countertops, 3-bed, 2-bath. And I was talking about how that air wants to shift from south or southeast back around to the west, so you get that nice rotating updraft. This is just a better illustration of that. You've got your 850 millibar winds in red, which, if we're north, here's about I-20 or so right there. So if we're north of I-20, we've got a southwesterly, followed by the blue arrow, which is up at 500 millibars. Well, westerly. What you'd like to see if you were looking for bad weather is maybe a southeasterly or a southerly followed by a westerly on the top of it. But either way, these storm crossover winds are actually decent enough for us to get some strong to severe storms. Relative storm motion is as suggested by the NAM from west to east. I think it'll be close to that, west to east. We'll probably get a couple guys going from southeast or southwest to northeast. But here's the most interesting thing of it all, folks. Notice where we've been talking about all of that energy, everything above us that is set up to give us severe weather. We've got winds aloft. We've got isobars that are spreading. We've got a solid wind aloft. We've got enough instability here at the surface. We've got helicity that's spinning in the atmosphere. Plenty of shear. We've got a little bit of vertical motion, not a whole lot. A lifted index that's looking pretty good. But the NAM says composite reflectivity. Now this is basically just a suggested radar, so to speak. Nothing. I wonder why that is. Well, we can figure that out pretty quickly. You head down here and you look at the surface winds. We'll clear this off. And if you want to find the front, that's where you've got winds that are coming out of the south and southeast, and those meet up with winds out of the west or out of the north and west. Is way back there. So we're still sitting out ahead of this area of low pressure, sure, and yeah, we've got a southwest wind aloft, we've got southeast winds at the surface, we're sitting in the right area, we're opening up the atmosphere all across, but we may be lacking a little bit of oomph to get any showers and thunderstorms going. In fact, as I go back, we can look at the composite reflectivity. We can go ahead a couple hours, another 3 hours, go another 3 hours ahead of that. Now things finally show up, but here we are at about 7 a.m. on Saturday. Great. But that's not when things are lining up aloft to give us any severe weather. Interesting. Now we can go look at the skew-T, and I like looking at the hodograph here because this is a measure of those winds as you move up. It's the same thing. All of these are wind barbs showing you the direction and the speed of the wind throughout the column of air from the surface all the way up. Notice that, and this works kind of like looking at a compass. This is a southwest wind. This is a west wind up here. Now if they were coming back around, that would be a northwest wind. All the arrows that come from this direction, a northeast wind. And then you look at the hodograph, and that is the same thing. All they're doing is they're saying, okay, we're putting a man right here, and which way is the wind going? Is it coming across you? Yes, it is. So then they're right there. You're just taking a dot from here and lining it to there, and then as you move up in the atmosphere, you're hitting each one of these points, and that's the direction of the wind. We'll go ahead and close that. That isn't necessarily impressive. Usually with tornadic cells, you'd like to see something a little more along the lines of maybe something like that. And we're close. We're kind of in here. But again, long arching hodographs, not necessarily what we're looking at for tomorrow. Also, you got your LCLs nice and low, and you've got enough temperature and enough moisture at about 850 millibars. You can probably do some damage with this, but the lapse rates aren't great either, so we're missing a fair amount of forcing, and lapse rates aren't looking very good. So take that for what it's worth. Again, our window, like I've been saying for the last couple of days, very small. Friday and into Saturday for any kind of tornadic event or any kind of severe storms outside of some very heavy rain and perhaps a little bit of hail. And we'll go ahead and take a look at the supercell composite. And again, this is the tendency for the atmosphere to create supercells. This whole area right here is up around a 9, and we've got a 12 in here, which is quite high, folks. And then you take a look at the tornado parameter, and then you've got anywhere. This is a 2, this line right here that kind of drapes around and across, goes out of our neck of the woods, and then we've got a 4 in here, also pretty high. You take a look, I'll clear that out. You take a look at mixed layer CAPE, and again, that's the amount of buoyancy that you have in that mixed layer, and during that time, and that would be right in here. The average, which is this black line right there, sits us at about 1,000 joules per kilogram. Okay, a lot of numbers coming your way, I understand. You're probably sitting there going, okay, Nick, I followed like none of that. Don't worry. Take a look at this. This is where it gets interesting. The Tornado Environment Browser. This is put out by the SPC, the Storm Prediction Center. It takes a look at all the tornadoes between 2003 and 2011, and it actually went back and looked at all of the atmospheric conditions that were happening, as well as some of the other parameters that we had to work with. And it came out with all these really cool statistics that give you an idea of when we should be concerned about tornadic development. Now, this isn't, scripture, this isn't gospel or anything, right? I mean, this isn't the end-all, be-all, but it does give you a pretty good idea of what to look for. Oh, now to the spreadsheet, folks. So what we went ahead and done is I've put in all the parameters down here that we were looking at all through here, and this is the only one we have to worry about. GFS haven't done yet. HERD, we're not close enough. WRF is missing some things. So the SREF I haven't had a chance to fill in yet. So again, I'll have a better idea of this as we get closer to the 5, 6, and 6:30 and 10 o'clock news tonight. But for right now, we're just going to look at the NAM, which take that for what it's worth. That's the North American model run. Up at 500 millibars, we're 10 degrees C, below 0. We've got a pretty stiff breeze at 270 degrees. Now that's a nice westerly wind. Now down here at 850 millibars, and again, that's a couple thousand feet off the ground, we're going to be sitting at about 16 degrees C, a dew point of about 12, a 30 knot wind at about 230 degrees, or a southwest breeze. Now, when you mix that in with the instability, and again, these are all the numbers that we just went through, about 800 joules per kilogram. You've got 3 kilometer shear, about 40 knots, about 60 knots. And again, these are all those maps that we were just looking at. The helicity, I just threw in 250. We'll take the top end of it. That gives you an EHI of 1.25. And again, you can just kind of keep this in the back of your mind. I'll move this up, and I'm going to slide this over so that we can get a better idea. EHI, supercells likely. But notice F2, F3, F4, F5 tornadoes possible. Not necessarily. We get down here to a bunch of our parameters. The sweat index, well, 377. A slight severe to severe possible. We're kind of we're mainly in the severe possible category, not quite to tornadic possible. And again, not the end-all be-all, but gives you a good idea. Total totals at 49. That's likely thunderstorms. I'd argue that we're probably at isolated severe storms. We're probably a little bit higher than that if by the time we get a little bit closer. K-index of 30. K-index of 30 puts us in moderate convective potential. 13.333 repeating, of course. Puts us in the optimum category. That's for all you Leroy Jenkins fans out there. Okay, so it would appear that given those numbers, all those things that we just went through, you plug and you chug, as they said in middle school for doing your old algebra, and you end up with a situation that looks like we could see a couple severe storms, but we're not talking about crazy tornadic storms. We're not talking about widespread severe weather, any kind of outbreak at all. And then you come down here and you look at the historical average, and again, we were just talking about that SREF, or that Tornado Environment Browser, and then we can compare that to the SREF and what it's kicking out. The higher numbers aren't always better, which is great news, because the historical average wants us to be between 0.1 and 1.5. We're at a 2. Between 1 and 6, we're at a 9. 250 and 1,000, we're at 1,000. We're barely in that last little bit. between 35 and 50. We're at about 50. Helicity between 150 and 350, sitting at 300 according to that SREF. And then mixed layer LCLs between 600 and 800. Okay, so we're at 750. So if you take this and you do a little checklist, because you can say, okay, we got that one. We're in there. We're in there. We're in there. We're in there. Those are terrible check marks, by the way. See if I can get those a little better. There we go. So we got 4 out of 6. Not bad, but we're also kind of barely in it with these two. So truth be told, we really are only hitting 2 out of the available 6 in the middle. Add to that, up here, our parameters aren't exactly screaming severe weather at us either. You go back a little bit farther, and you say, okay, it's not screaming severe weather, composite reflectivity, well, we'll head back here a little bit, I'll send it back to where it should be. At midnight, isn't breaking out any showers and thunderstorms. So what's the big whoop? Unfortunately, there's still a big whoop a little bit. I'll pick this up a little bit. When you take a look at all those parameters, and again, they're all back over here, and you kind of lay them on top of each other all at the same time, you end up with something that looks very messy, but nevertheless, I think it gives us anywhere between a slim to low to moderate risk for severe weather across parts of the area. And you can see the area, our area back and behind it, we got, Hattiesburg in here, Columbia over here, Laurel up in here, Bay Springs up in here, McGee, Loosedale down over here. So you can see kind of where things line up for where we're looking at the opportunity for a little bit of severe weather. And again, this will get refined as we go through the evening and through tomorrow. But right now, given all the parameters that we just looked at just a couple of seconds ago, and all of the numbers that it kicked out, again, a slim to low to moderate or medium threat, that's not exactly a screaming severe weather outbreak to me, which is great news. The problem is that you can't let your guard completely down, because a couple of different reasons. These are going to be overnight, Friday and into Saturday morning. It could even linger around until Saturday morning as you're getting out of bed, depending on where you're at, especially for in some of our eastern counties or southeastern counties. So they're going to be at night. If any of these storms that do initiate can remain discrete, can stay kind of isolated, away from other showers and thunderstorms in the area, they'll have a better chance of developing supercellular characteristics, which means that you'll have a better chance for maybe breaking out some larger hail, some heavier rain, some more frequent lightning, and the possibility for an isolated tornado. But that's the way that it's looking right now. I think the main concerns are a whole lot of rain, a whole lot of wind in some of these storms, perhaps approaching 60 miles an hour, straight line winds, a little bit of hail, but probably not necessarily large, maybe quarter-sized hail at the best. And again, if storms can stay discrete, can stay away from other storms, they can get up going on their own, an isolated tornado or two can't be ruled out. And I think, before I get off of here, I think your best bet for that is going to be probably kind of in this ballpark area right in here. That would include Foxworth, Columbia, Purvis, Lumberton, Poplarville, not getting quite into Hattiesburg, not getting quite into Collins, staying south, I think, Prentice. That said, beyond that little area, most of the action is going to be well off to our northwest. I mean, well off to our northwest. I think the heaviest stuff is actually going to be north of I-20 and back off to the north and west of Jackson. So anyway, I know, a long breakdown. We covered a lot of ground. So I hope maybe you learned something, or at least you feel a little more comfortable depending on where you're at. And if any of the storm chasers are watching this, be very, very careful, because storm chasing at night is a very, very, very dangerous task. So anyway, thanks for checking this out, and if you do have any questions, of course, you can always find me on Facebook, Twitter, or you can comment below.